Bisection method. So we are starting with by solving one example. Example number 1 is compute one root of sin x equals 10 into x minus 1, correct up to 3 significant figure. We all know the procedure. At first we have to find out our fx, that is the given equation. Then we have to find out one interval such that the endpoints of that interval, the functional value of the endpoints of the intervals are different. That is f of a0 into f of b0 should be less than 0. That means there lies one root. So then we will bisect that interval, we will get the midpoint. Again we will check the sign of the functional value at that midpoint, and then we will take different signs to make a new interval. We will apply this procedure simultaneously until we get a required result which is correct up to 3 significant figure. Okay, so here our fx is sin x minus 10x plus 10. So we have to find out one interval where the endpoints functional value signs are different, starting with 1, f of 1. To find the value we will use the calculator. Now in the calculator what you have to do, you have to make it in radian. Check, there should be, the sign is not in degree. The angle we will put in radian. For that, if it makes degree in your calculator, that is if it's showing d sign here, then you can change it from mode. There. Check this one. 2 is degree. 2 is radian and 1 is degree. If it's in radian, then okay. If it's in degree, change it to radian. Just press 2 there. It will be okay. Now find out the values. So I'm putting sin 1 minus 10 plus 10. So it will be only sin 1. It's 0.84, which is positive. Next, f of 1.1. It will be sin 1.1 minus 10 into 1.1 plus 10. So minus 0.108 minus 0.108, which is negative. So we get one interval where they take different signs. That means our required interval is 1, 1.1. Now here we get only after 2 steps. Not necessarily for all the problems you will get after 2 steps. You have to check for other points also. 1.1, 1.2, 1.5. If not found the different sign, then for f2, f2.5 and so on. Okay. So this is our required interval. Now we need to check that f dash x keep the same sign throughout the interval or not. So f dash x is sin x, its derivative is cos x minus 10. Now we know the maximum value of cos theta is always 1. That means this quantity will always be negative. So it is less than 0 throughout the whole interval. That means f dash x keeping the same sign. So by using Bolzano's location of roots theorem, we can say that in that interval the function has only one root, one possible root. Now we are trying to find a perfect approximation for that root. For that reason we are writing it as n. N is the serial number, then an is the left end point of the interval, then bn, which is the right end point of the interval. Now at initial, when n equal to 0, it will become a0 and b0. Now we are putting the sign for a0 and b0. a0 is 1, its sign is positive, so writing plus here, and b0 is 1.1, its functional value sign is negative, so putting minus here. Next one is xn plus 1, whose value is an plus bn by 2, that means the midpoint of that interval. And next f of xn plus 1. Okay. So now for starting n equal to 0, then its value is 1, its value is 1.1, and then find out the value of xn plus 1, that is 1 plus 1.1 divided by 2. So it will become 1 plus 1.1 equals divided by 2. that means 1.05. So it will be 1.05. Now check the value of the function at the point 1.05. So it will become sine 1.05 minus 10 into 1.05 plus 10. So it is 0.3674. We will take 2 decimal place if we take, so it will become 0.37. So it is 0.37, which is greater than 0. We don't want the value, we don't need it, we need its sign so that we can find the end point of the new interval. Now it becomes positive. That means we have to consider this one as one end point and this one as another end point. Then f of a0 into f of b0 will be less than 0. That means we need the different signs for the different endpoints. So we will put that value 1.05 on that position. That is, the new interval will form. It will become 1.05 and 1.1. Okay, for the step n equals 1. Now check their midpoint also. That is 1.05 plus 1.1 divided by 2. So it will become 1.075. We can write it by rounding off 1.08. Then find the functional value at that point 1.08. So it will become sine 1.08 minus 10 into 1.08 plus 10 equals 0.08195. After rounding off, we can write it 0.082. Okay. Again, this is also positive. That means this value, that is ultimately this value endpoint. This is actually the functional value. That means this will be our new positive endpoint. We should keep the negative endpoint as unchanged. That means negative is this one, this. So we will keep this one same, and the new positive endpoint will be 1.08. This is endpoint n equals 2 step. Now find its midpoint 1.08 plus 1.1 whole divided by 2. After rounding off, we will get 1.09. Find its value, functional value, that is sine 1.09 minus 10 into 1.09 plus 10. Its value will get minus 0.013, which is negative. Now we will replace the negative endpoint by this one, which is negative endpoint, this bn. So in the new bn will be 1.09 and the positive endpoint will keep same. So 1.08. This is step number 3. Now find out its middle point 1.08 plus 1.09. It will become 1.085. Find its functional value. You will get 0.034, which is positive. In the next step, we will put this one in the positive line, that is here. So 1.085. We'll keep this unchanged. This is fifth step actually, starting with n equals 0. This one, then its middle point 1.085 plus 1.09 whole divided by 2. So it will become 1.0875, and its functional value, it will be 0.0104, which is positive. Now applying the same procedure. Now when to stop? We have to stop at 3 significant, correct up to 3 significant figures. So the rule for stopping is that the an, bn and xn plus 1, that means this 3, this an, bn and xn plus 1, these values will be equal up to 3 significant figures. Then we can stop at that process. Now check after doing the 5th step, what will we get? This is our positive value. So putting it on the positive line 1.0875, and this is 1.09. This is our 5th step. Then finding their middle point, it will become 1.08875, and its functional value will be minus 0.00145. This is negative, so we have to replace negative line by this, that is 1.08875, and this one 1.0875. Sixth step, its middle point is 1.08812. Now check at that step, this fifth step, the third positions, the three significant figure, we get three significant figure correct with the previous steps, right? That means this one is correct up to three significant figure, this and this same, this one also, and this one also correct up same up to three significant figures with its previous step. So this will be the ultimate step. That is, this is the terminating step. We got the result up to correct up to three significant figure. And what will be our result? Our result will be that xn plus 1's ultimate value, which is this one. Now make it up to correct up to three significant figure. This is 1.08875, right? Three significant figure means this, so it is equivalent to 1.09. That means this is our required root of the equation. Okay, this is how we apply the process or method of bisection. Just take one interval. At first find one interval such that the endpoints functional value signs are different there. Then take this interval and then just make it half. Just make it bisected like this. If we draw over real line, suppose at first you get this interval. Root is lies somewhere between this area, so let's root is here. Now whenever you will find the middle point, this will be our middle point. Now when the root is lies here, obviously this sign and this sign will be different according to the theorem. Then you will get the new interval like this. Then find its middle point. Suppose somewhere here it is middle point. Then root is lies between here. So this sign and this sign will be different. So you will get new interval. Then again make it half. So half is somehow this position. Now root lies between this line and this line. So its sign and its sign will be different. So the new interval will be like this. Now in each step the interval becoming smaller and smaller, and we are getting closer to our root. This is the actual procedure of method of bisection. Okay. So this is how we get the result.